Let's talk about the satisfiability of equality equation. So you are given the string array of equations. So they represent a relationship between variable where each string equation I is a length of 4, and every single string has two variable, and you have to have you have a equal bit operation and not equal bit operation, right? So you have to assign uh, x equal to y, but in the meanwhile, if you find out y is not equal to x, you have to return false. So this question, you have to use a pretty efficient way algorithm to actually code it. So in your code, you can minimize the mistake a lot, right? So you can actually use hash map, and then when you traversing the first string, right? When you say a equal to b, you also have to say b equal to a, right? At the same time, and then when you find out, okay, b is not equal to a, and then in your hash map, okay, this is the first iteration you put into your hash map, right? And then when you find out b is not equal to a, in the meanwhile in the hash map you have b equal to a, so you have to return false. But this is actually taking a lot of effort to code for sure, because there are some corner case for sure, right? So there's a better way. So the most efficient way, in my opinion, is called UnionFind. So UnionFind is actually really helpful. So if you want to go deeper about the UnionFind, you have to go on other source page to go. I mean, to dig on it. And in this one, I'm going to just briefly talk about how I actually how I understand about the UnionFind. Be honest, right? So I'm going to just assign the size of the UnionFind. So how do I assign? So how many node do I have? I have a 26 node, be honest, because there are 26 lowercase later, right? So when I trying to traverse the entire equation, I mean, before I traverse the entire equation, I'm going to just create 26 node of the uh 26 node in my UnionFind, and then for every single node, I'm going to just point the ancestors to myself first, right? So I know there's no loop with other node, and then when I call my this node, it will return itself, right? So in the beginning, I would just by default doing like this, right? So how do I actually make these two nodes connect together? So I would have to assign. Okay, this is number one. This is number two. I will have to assign it, my number one be my ancestor of number two, right? So um, okay, this is not the way you actually write it. So I say number one be my ancestor of number two, right? So I'm going to say the parents of two. So I'm going to create an array, right? This is entire thing is array, right? So I'm going to say parent two is equal to 1. So when I assign, right? When I assign, I'm going to change another color. This pointer is directly pointing at 1 for sure. So this is actually what? This is actually a small tree, be honest. So I can just keep going up when I give in the setup. When I give the node to value, right? I can keep going up to the ancestor, and then to find out who is the tree node. I mean, be honest, the root, be honest, root for this current subtree for sure, right? So I will have a find, another function called find. I'm going to pass in node 1 and node 2, right? Then I would okay, actually I don't need node 2. I can only need node 1. I can only have node 1, let's be honest, because I would just keep calling my parent array to parent array for my node 1. So I will just keep assigning, right? Parent and then node 1. So this is going to my grandparent, be honest, right? This is father. You can call mother as well, but in this one you go to grandparent, right? This is parent, this is grandparent, right? And you have to update your node 1 to your parent, so you will keep going up, right? And then when you want to find out the UnionFind, right? So when you want to connect together, right? You have a union function, and you are passing 2 points, right? It's going to be node 1 and node 2, and then when you call this function, if they are not equal, if at the end if they are not equal, then you can actually assign my parent 2 equal to parent 1. I mean parent 2 equal to 1, right? And this is pretty much the solution. And let me start code it, and then you'll find out what is the problem right here. So I'm going to call UnionFind class, right? And I have a parent array, and then I'm going to call parents, right? And then I don't know the size, right? And then I would have to create a default constructor, and I pass in the size. And then if I know the size, I'm going to say new int, and then I'm going to just quickly traverse the entire inner array, and then set the default size to yourself, right? Okay. Now this is a base case. I set the ancestor for every single node to itself. Now, again, I say you need what? You need union. You need to connect, right? And then you need to pass in two nodes. I'm going to call node 1 and node 2, right? And then what else? What else? Fine, right? You need node 1. All right. Let's start code for node 1. So for the node 1, right? We already know the parent array, and then for this current node, like I can actually access to the parent array, so I can know, okay, who I actually pointed which node, right? So who is the ancestor of node 1, right? So I can just using the while parent and nodes 1 is not equal to node 1. So you can actually keep traversing. So this is actually what? When parent equal to node 1, right? When parent node 1 is actually equal to node 1, this is actually default value. But when they are not equal, you can actually find out your grandparent for sure, right? So parents at node 1 is actually equal to what? It's actually equal to grandparent, right? Grandparent and node 1. And after this, I'm going to just update my node 1 to parents and node 1, so I can keep going up to the grandparent, grandparent, and so on, right? Then later I will have to return node 1. So this is pretty much it for the find, right? And then for the union function, I'm going to call the find, and then I need to call root 1 for my node 1, right? I'm going to call find node 1, and then entire same thing for root 2 equal to find node 2. So I will have to find out who is my root 1 for node 1, who is my root 2 for node 2. If they are not equal, I can actually change their ancestor pointer to the other, right? So if root 1 is not equal to root 2, right? I'm going to assign my root 2 equal to root 1. So I'm actually connect together, right? Then I need another function. I'm going to call boolean. I'm going to say is connect, and then in this one I need to pass in two nodes, right? And then I will have to return by using the find function. If they are equal, I'm going to say if find and node 1 is actually equal to find node 2, right? This is pretty much the UnionFind class you have to do. And this is actually pretty straightforward. So if you didn't know, like you don't want to go too confused, because I will probably say you will get confused at this point. But think about this: when you go on parent, you want to go on grandparent, right? You have to keep updating your node 1 to your parent, so you can keep going up, right? So that would be it, right? So all right, this is too much talking now. So back to the solution class. So I have an n. So n represents the equation dot length, and I'm going to call UnionFind. I'm going to call uf equal to new UnionFind, and now I'm passing the size of n into my UnionFind, right? All right. So I'm going to traverse the entire string array, right? String equations, and then in my equation, right? I will have what? I will have I will have a first variable and I will have second variable, and then for the equal sign and then not equal sign, the main difference is this character, right? So this is actually what? This is actually a fixed position. So if equation, I'm going to just call a equal to what? Equation at chart at 0, and I need to subtract the a, and then b equal to equation at position what? Position 3 minus a, right? And then since I'm putting the inner array inside the union class, I can just call int, to be honest, and then this will actually make my work so easy. And then I'm going to just what? For the first for loop, I'm going to find out if they are equal, right? If they are equal, so equation dot chart at first position, if they are actually equal to equal sign, right? So I'm traversing the equality first. I'm not checking the not equal sign first. So if they are not equal, I'm going to ignore, because I'm going to traverse not equal later, because probably not equal will go first and then equal will go second, right? So this is actually the sorting. This is actually based on your sort, but we don't want to sort this equation because this will take a log n, and then this is not efficient. So if they are equal, I'm going to call uf dot what? Union, right? And I'm going to pass in what? A comma b, right? I'm passing a comma b. I'm going to connect a and b together, and this is pretty much the first iteration. And then again, I'm going to traverse again, but this time I'm going to say, okay, if they are not equal, at the first index, if they are not equal, then if they are not equal, then if I find out is connect function uf dot is connect a comma b, if they actually connect in the UnionFind class, I'm going to return false, and everything else I'm going to return true. And here we go. I might have a mistake, but I don't care. Let me submit. Alright, okay, I don't have it. Alright. Yes, I do have a mistake. So this is gonna be what? This is gonna be okay. I have a mistake right here. So again, I say how many size? This is not unsize. This is actually 26. The size of 26 because they are lowercase. Alright, I made a mistake. But whatever, man. This is life. Alright, okay, so I passed the test. So let's talk about time and space, right? And this one, for this one, this is going to be space all of 26. So it should be the characters for lowercase, right? And then in this function, in this class, right, this is actually all of n, all of 26, right? For the time and for the space, right? This is space, this is space, this is time. And in this one, this is actually what? This is actually log of 26, to be honest, because you don't need you probably don't need you probably when you traverse for the find, right? Because when you go on find, you can just go on your ancestor. You don't need to go every single node, right? Only if they are connect every single node together. But in the meanwhile, you update for sure. In the meanwhile, you update your current node, and then this will be, I would say all of, okay, this is, I would say all of them. Alright, anyway, but this is actually depend on your node. Alright, and this is what, this is actually depend on your find. So this is time, but you can actually go deep, go find out your solution for time complexity right over here. But this is not the main problem. So in this one, this is all of n represent the length of the equations. And this one I union, right? So union, just call the union union function, and this will give you the time complexity based on your find, right? And then this one is what? This one you call it again. This is all of them, right? So I have a quick note for my time and space complexity. So if you do not agree with me, then you will probably have to find out another solution. So n c log c. C represents length of the lowercase alphabet, and space is all of c. This is because I use a space of 26, right? And n represent the n represent length of the equation, right? And then c log c. C log c is actually it's actually the case in find, to be honest, right? And then this is pretty much the solution. So if you feel this is helpful, and leave a like, subscribe if you want it. So if you want to go deeper into UnionFind, how you actually build, how you actually work the function, or the actually something else, you can go on our source page to go on it. I mean, to study. So in this one, I'm just briefly talk about the UnionFind class. So this is pretty much it, and I will see you next time. Bye.